All right, let's start with a little test. Take a good look at this. What do you see? I mean, at first, it's pretty clear, right? Looks like a painting of a woman, maybe looking out a window at the sea. Got it? Okay, hold that thought. But what happens if we just step back a little bit? How about now? Whoa. Suddenly, it's not a woman at all, is it? It's a portrait of Abraham Lincoln. So what on earth just happened? Your eyes were looking at the exact same information, but your brain just told you two totally different stories. And that little trick, well, it pulls back the curtain on a fundamental truth about how we see the world. This is the story of the great lie, this constant, invisible gap between what your eyes physically see and the seamless reality your brain constructs for you. To get a sense of just how big that gap really is, let's start with a number: 10%. What in the world could that have to do with vision? Get this, that's the percentage of your waking hours that your eyes are physically shut because you're blinking. Yeah, you spend 1/10 of your day living in tiny moments of complete darkness. But you don't experience it, do you? The world doesn't flicker on and off like a bad signal because your brain is a master editor, just seamlessly filling in all those gaps. So here's the crucial point. We all think of our eyes as these perfect little cameras just recording the world, but that's not the whole picture. The real director of the show, the one interpreting, editing, and literally creating what you think of as sight, is your brain. But to really understand what the brain is doing, we first have to look at the hardware it's working with. And the best place to start is with an analogy we all know: the camera in your head. So let's follow the path of light, just like in a camera. First, it hits the cornea, that's the clear front window, and it does most of the heavy lifting with focusing. Next, it passes through the pupil, and the iris around it acts just like a camera's aperture, shrinking in bright light and widening in the dark. From there, the lens does the fine-tuning, changing shape for things up close or far away. And finally, all that light lands on the retina at the very back of the eye, which is kind of like the camera's film. Simple enough, right? A perfect little biological camera. Except, well, that's where the analogy completely falls apart. The truth is much stranger, and frankly, way less efficient than any camera you've ever owned. Think about a camera sensor for a second. It captures a whole scene in crisp, high resolution, right? From edge to edge. Your retina? It's completely different. It only captures one minuscule point in true high def. Everything else, your entire peripheral vision, is incredibly low resolution and blurry. That tiny point of clarity comes from a small pit in the center of your retina called the fovea. It's just jam-packed with the highest density of photoreceptor cones. Those are the cells responsible for sharp, colored vision. This little spot is the only part of your eye that sees the world with any real detail. So this is the reality of your vision. It is not a wide, clear window. It's more like a single, high-resolution spotlight that your eye is constantly darting around a dark, blurry room. And you don't even notice this is happening because your eye moves incredibly fast, in less than 1/100th of a second, to aim that little spotlight at whatever it needs to see. So, if the film in our eyes is mostly blurry with one tiny clear dot, how do we see a full, coherent picture? Well, that's where the brain takes over to develop the image. Here's how it works really fast. When light hits those photoreceptor cells in the retina, they don't record a picture. They convert that light into raw electrical impulses. Those impulses then shoot down the optic nerve straight to the visual cortex in your brain. And it's the brain that takes this messy, incomplete stream of data and interprets it, stitching it all together into the rich, detailed image you perceive as reality. And remember, the brain isn't just a passive receiver. Unlike a camera, which can only record what's there, your brain actively fills in the missing information. It smooths over your blind spots, it edits out the blinks, and it stitches together all those little high-resolution spotlight moments to create one seamless panoramic view. So what does this all mean? Now that we understand this partnership between the eye's limited hardware and the brain's incredible software, we can finally see why seeing isn't always believing. Let's go all the way back to that Lincoln illusion. Now we get why it works. When the image is large, your high-res spotlight, your fovea, focuses on the individual blocks of color, and your brain interprets the details: a woman, a window. But when we blur it or shrink it, we deny the fovea its detailed data. We force the brain to rely on the low-resolution peripheral information, which is excellent at seeing broad patterns. And the biggest pattern here isn't a woman. It's the face of Abraham Lincoln.
So if you had to break it down, you could think of it like this. The actual act of seeing is maybe 20% data collection by the eye, and a whopping 80% processing, interpretation, and outright creation by the brain. Your reality is an educated guess, a story your brain tells itself based on patchy, incomplete data. Which brings us to our final question. After all this, the editing, the filling in the blanks, the spotlight in a blurry room, can we really say that seeing is believing? Or is the world we experience every day just the version our brain wants us, or maybe even needs us to see? It's something to think about.